So this chapter focuses on the galaxy that our sun is a member of, the Milky Way galaxy. And honestly, it's kind of hard to tell what our galaxy looks like because we can't get far enough above or below or outside of our galaxy to get a good grasp. We get clues to what our galaxy looks like a number of different ways, including looking at other galaxies. But in the nighttime sky, the darker skies the better, you will see this kind of swath of kind of milky looking, kind of cloudy looking band across the sky from horizon to horizon. And it kind of varies with the seasons, but it's called the Milky Way, and we're looking into the disk of our galaxy. And what might appear as kind of like dark regions in the Milky Way in the nighttime sky, actually those are kind of oftentimes dark nebula, so they're not glowing for, they don't have any energy to make them necessarily glow, but they're nebula, and so they obscure our view beyond them. So it's a tricky thing, but we can kind of massage information coming from the disk, the Milky Way, in different regions of the electromagnetic spectrum. So our galaxy is a type of galaxy we'll learn in the next chapter called a spiral galaxy. Specifically, we think it's a barred spiral galaxy. But spirals and barred spiral galaxies have a disk component, and we have a bulge component. And I think we've been alluding to this, and we'll talk more about this in chapter 14, that in the center of our Milky Way galaxy actually is a black hole, a supermassive black hole. Outside the disk area we call the halo, and there's an assortment of things in the halo, including dark matter. And I think in Unit 1 we talked about dark matter a little bit. We'll be talking more about that in Unit 5. But there's two types of clusters of stars. There are globular clusters and open clusters. And globular clusters, remember, they're the groups of stars that tend to have really tend to be pretty old. So our sun is located about halfway from the bulge to the edge of our disk. Okay, about 27,000 light years from the bulge. From side to side, just like the Monty Python song says, the Milky Way galaxy is about 100,000 light years, and it's about 1,000 light years thick. So if we were to look at the Milky Way galaxy, now that was edge on, and this is more what we call face on spiral galaxies. And again, we understand more about maybe what our galaxy looks like by looking at other galaxies, specifically other spiral galaxies. So there's the disk component, okay, and the spiral galaxies have these spiral arms, and the spiral arms are highlighted by relatively bright stars. You can see that bulge or nuclear bulge in the center of the galaxy, and most galaxies they're finding actually do have a supermassive black hole like the Milky Way. And then there's the halo region, and in the halo region, among other things, are these globular clusters. So we've talked since chapter 1 in this class about how we have this, orbital motion of an object is dictated by the masses that are involved in the orbital motion. That would include the mass of the object and the mass that the object's orbiting around. So we definitely, all stars in all galaxies need to be orbiting, need to be in motion. And you can see a couple of different things here. If you see the yellow kind of, those would be disk stars. Disk stars tend to kind of be pretty orderly, kind of bob up and down a little bit within the disk, up and on the top of the disk, below the disk, through the disk, but they're going all kind of in the same direction. So on our Milky Way galaxy, all stars in the disk kind of orbit the same direction. If you compare that to kind of halo objects, halo stars or groups of stars, you can see where they're a little bit more willy-nilly in direction and closeness to the supermassive black hole in the center of the galaxy. And so speaking of orbiting, here we see, let me go back. Here we would see, again, this is not a photograph, but looking at the Milky Way face on, you see the location of our sun drawn about 27,000 light years from the bulge. And our sun is orbiting the center of the Milky Way galaxy along with its nearby neighbors. And it would take, based upon our distance from the supermassive black hole, it would take about 230 million years to complete one orbit and kind of come back to the same space in the disk, relatively speaking. And the other thing is you can kind of see our neighbors are kind of out in our vicinity kind of bob up and down a little bit, but we all kind of go around with a similar velocity. So one of the things that we can, just like we got to the masses of stars that are in a binary system by studying their orbital period, so also we can get to the mass that is contained within the sun's orbit, looking at the sun's orbital period. And so it looks like that mass is about 1 with 11 zeros behind it, solar masses. And this just says, how did we get to that mass based upon the orbital velocity of the sun, the radius of the sun. G is the gravitational constant. So that gives us that amount of 1 times 10 to the 11th solar masses.